Hi, welcome back. So today we will be talking about how a decision maker can navigate the world of tech stacks and databases and warehouses and what these things mean, purely from a decision maker's perspective and how that can actually lead to a data strategy. We already are working on a case study where we have data that is collected from X number of sources, and we are making a knowledge hub a portal. So, with this perspective, with this specific example, because our own data might have a database or not, we are still going to utilize that as one of the several sources that we have. So when that case is clear, what we will do is we will make a warehouse. Now that warehouse is going to have a number of data marts. Now, what does a data mart mean? So basically, that is the implementation of a warehouse. So you don't need to worry about that. Let me show you with a diagram, with the help of a diagram. This is commonly referred as a UML diagram or a RD. But you can see that one table is connected to multiple objects. And then there is something called zeros and ones, and there is a star. This explains the relationship between one entity and another entity. And so everything is an entity. And this is that you can see some are connected to more than one table, and they have certain relationships defined. And this is the basics of how a database looks like. So this is the same data, but in a warehouse. And you can see right off the bat that there is just one table that connects to all of the different other tables, while the other tables are not connected to each other, but to this central table only. Now, this is the visual difference. And you can also search on Google and you can see star schema, what it means, what it looks like. You're going to find something like this. There's a fact table and then there are dimension tables. And then if you say database schema, then you can see something like this. All of these are interconnected with each other. These are connected. And then or maybe this is a better relationship diagram in which there's a whole mesh of relationships and everything. Now, from just observing this, another question comes into my mind. If I have certain data over here, and I want to get data from this and this table both. For this is, for example, a person, and this is the products or the products purchased, and I want to understand. So I have to navigate through all of these connections. These are called joins in a code, and this is going to be comparatively quite complex. However, if I am looking at a previous example in which we have only one central table, so we know all of the relations are derived from this central table. Now, this table is going to be an absolute mammoth, is going to be big. However, it is going to support our analytical requirements. So people who are, it's easier for business users and business teams and not wizards who are amazing at SQL. They can also work on this, have like central data mart to answer all of their questions. So this is one of the benefits of moving away from a database structure to a data warehouse structure. This is going to be cheaper as well as faster for analytics compared to a database. As a matter of fact, for database, if you directly build your analytics pipeline on a database, then it will be plagued by multiple sources of truth, maybe even, but it can also be plagued by redundancy as well as bottlenecks in terms of performance. So that is the difference between a database and a warehouse. And we might not need to make a very comprehensive warehouse, but we would still need to make the minimalist level of a warehouse, which is called a data mart. Now, having explained the difference of choice and the purpose of between these two, the others become easier. So a database is like a PostgreSQL, MS SQL, MySQL. These are things are referred as as a database. And a warehouse is going to be Amazon's Redshift, Google's BigQuery, Snowflake, as well as Azure's Data Factory, or Azure has some other offerings as well. Then you have a data lake and a lakehouse. So warehouse and database require a lot of deliberation in terms of design. However, data lake is somewhere that you can AWS S3, Google Storage, Blob Storage by Microsoft. These are places like you just dump all of your data. And then when use cases arrive and you say, okay, now I want to query my data, you use something like Snowflake, Spark, Databricks. These are really popular tools which are designed for this, that you can just take your data out and build your design. But even then, you would need to make something of a warehouse design. So this is the purpose of when you use a data lake. So you can say data lake is a buzzword, a kind of fancy word that revolves with a warehouse and as well as a storage. So it is like the implementation of a warehouse. And this became more and more, you can say, obvious with time, that we were just talking about a special implementation of a warehouse. That it later bit now there's a new term that is being that's the combination of a data lake and a warehouse, which is called data lakehouse, which is out of the box like solutions which use this configuration of a data lake plus a warehouse where which is called delta lake, and this is like a packaged solution which is doing the same. So these are different technologies. The configuration, it really does depend on what your team is used to and what and because from a cost perspective these are expensive tools as well as the resources, the technical people that you need to hire are also going to be in a lot of demand. We are going to talk about a little bit of cost one last time. So a database, it costs, for example, if you have configured it in a server, so just hosting that server, that would be the cost of the database. Same goes with a warehouse. But warehouse with cloud platforms like Redshift, BigQuery, these guys have free tier and quota limits as well, which is free per month. And then you after that you kind of pay. So I've set up warehouses for a lot of clients, and generally it's the cost is either less than $20 or $50 for SMEs, but for enterprise, there's just massive amount of data, and there's hundreds of users using reports, premium reports every day. So the cost is around $1,000, $1,500 per month as well, which is all justified in terms of the scale of the and the value as well. But there have been even more premium and bigger total cost of ownership in terms of data. But I'm only talking from the perspective of the warehousing cost and the cloud platforms cost. So I think that covers this, and see you in the next video. Thank you.